Welcome back to class, my amazing students. We shall proceed to Propositional Logic Part 2, and the lesson outline include logical equivalent propositions, negation of compound proposition, negation of biconditional proposition, negation of conditional proposition, tautologies and contradictions of arguments. Logical equivalent propositions. Two propositions are said to be logically equivalent if they both have the same truth values in every possible case. Two propositions are said to be logically equivalent if they both have the same truth values in every possible case. Now let's consider an example there. Example 1. Use the truth value to show that negation of P and Q is equivalent to negation of P or negation of Q. We'll start by using true and false value for both P and Q. For P, we have true, true, false, false, and for Q, we have true, false, true, false. For P and Q is always true when both statements are true, and that's the reason why P and Q is true and the other ones are false, false, false. Now for negation of P and Q, we have the first negation is false, the second negation is true, the third is true, and the fourth is true. Now for negation of P is false, false, true, true, and for negation of Q, false, true, false, true. Also, don't forget that disjunctions are always true if one of the statements are true. And that's the reason why negation of P or negation of Q gives false, true, true, true. Now, let's observe closely. Negation of P and Q and negation of P or negation of Q from the table. Negation of P and negation of Q gives false, true, 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 and negation of P or negation of Q also gives false, true, 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 which means that both statements are the same. Negation of compound proposition. Example 2. Write the negation of the proposition Kunle is a tall boy and Titi is a short girl. Write the negation of the proposition Kunle is a tall boy and Titi is a short girl. Now let's proceed to the solution. Let P be Kunle is a tall boy and statement Q be Titi is a short girl. Then P and Q means Kunle is a tall boy and Titi is a short girl. The negation of both statements is negation of Kunle is a tall boy and Titi is a short girl, because that is P and Q, which is logically equivalent to negation of P, that is Kunle is a short boy, or negation Q, that is Kunle Titi is a short girl. Now, negation of P or negation of Q still means Kunle is not a tall boy or Titi is not a short girl. Now, this means that negation of Kunle is a tall boy and Titi is a short girl is also equivalent to Kunle is not a tall boy or Titi is not a short girl, because they have the same truth value. Negation of conditional proposition. If P and Q are the two propositions, use the table technique to show that negation of P implies Q is equivalent to P and negation Q. Now, looking at the two symbols in the two sides, you see the first one is conditional proposition and the second is conjunction. Negation of P implies Q is equivalent to P and negation Q. P statement is true, true, false, false, and Q is true, false, true, false. P implies Q is true, false, true, true, and negation of P implies Q is false, true, false, false. Also recall that conditional statements are always false if the antecedent is true and the consequent is false. Now let's consider negation Q. Negation Q is false, true, and P and negation Q is false, true, false, false, because conjunctions are always true if both statements are true. That is, P is true and Q is also true. And if you look at negation P implies Q, it has the same truth value with P and negation Q. False, true, false, false for negation P implies Q, and false, true, false, false also for the second one. Negation of biconditional proposition. Example 3. Biconditional from the word means two conditional statements. P implies Q and Q also implies P. So let's look at the example. If P and Q are the two propositions, use truth table techniques to show that negation of P implies Q or Q implies P is equivalent to P implies negation Q or negation Q implies P. So we have established statement P and Q. Now, biconditional statement is false if one of the statements is false, that is P and Q, and that's the reason why P implies Q or Q implies P is true, false, false, true. Now, looking at the negation of this statement, we have false, true, true, false. Now, negation Q is false, true, false, true. Now, looking at P implies negation Q or negation Q implies P is also biconditional statement. Now, let's look at P implies negation Q. This statement, since there is biconditional statement, is always false if either of the statement is false. Now, looking at P and negation Q under the first and the fourth column, we have false and false, and that's the reason why biconditional statement is false, true, true, false. Therefore, these two biconditional statements have the same truth values and is said to be logically equivalent. Tautologies and contradictions. A compound proposition that is always true for all possible truth values of its variables is called a tautology. A compound proposition that is always false for all possible truth values of its variables is called a contradiction. I repeat again. A compound proposition that is always true for all possible truth values of its variables is called a tautology. A compound proposition that is always false for all possible truth values of its variables is called a contradiction. That means that the truth values of tautologies are always true and the truth values of contradictions are always false. Example 4. Show that P or negation of P is a tautology. For P, we have true, true, false, false. For negation of P, we have false, false, true, true. Then P or negation of P is true, 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 true. The reason for that is because disjunction is always true if one of the statements is true. And that's the reason why P or negation of P is true, 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 true. Example 5. Show that P and negation of P is a contradiction. P is true, true, false, false, and negation of P is false, false, true, true. Then P and negation of P is false, 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 false. And the reason for that is because conjunctions are true if both statements are true. Now let's look at P and negation of P. We have true and false, and we also have false and true. And since that is the case, all statements are false. Thank you for listening.